Myself Shubhashish Shah, Assistant Professor of Mathematics of Greater Kolkata College of Engineering and Management, GIS Group. In this video, I will discuss about matrix representation of a graph. In previous video, I have already discussed the basic of graph theory. For computer processing, matrix representation is very convenient and useful. Many results on theory of matrices can be readily applied to study the structural properties of graph. So there are various types of matrix representation of a graph. Now, what is matrix representation of a graph? Matrix, to represent a graph, the way of drawing the vertices and edges is not only the way to represent a graph. We can also represent a graph by just writing a matrix. So now I will show you how we can represent a graph by a matrix. So the first I will discuss the incidence matrix representation of a graph. I have taken this graph to show the incidence matrix representation of this graph. Now let the name of this graph is G. Now see that G has 7 vertices and 8 edges. I have given the name of the vertices and edges in the graph. VI's, that is V1 to V7 are the names of the vertices, and E1, E2 up to E8 are the names of the 8 edges. Okay. Now I will represent this graph by a matrix. Now what is the procedure of writing an incidence matrix of a graph? So the first thing I have to say you, that is the number of row in an incidence matrix is equal to the number of vertices. Listen carefully, this is the most important thing I will tell you. The number of rows in the incidence matrix is equal to the number of vertices, and the number of columns is equal to the number of edges. That is, since here there are 7 vertices, so there will be 7 rows in the incidence matrix, and since there are 8 edges in the graph, so there will be 8 columns in the incidence matrix. So the order of the matrix will be 7 by 8. 7 rows, 8 columns. Number of rows equal to number of vertices. Number of columns equal to number of edges. Okay. Now I will write the matrix. So here number of rows is equal to number of vertices is equal to 7, and number of columns equal to number of edges is equal to 8. So the order of the matrix will be 7 by 8. There will be 7 rows and 8 columns. Okay. Now I am writing this matrix. So since there are 7 rows, and I am giving name the rows as V1, V2, V3, V4, V5, V6, V7, and the name of the columns as E1, E2, E3, E4, E5, E6, E7 and E8. Okay. Now the question is, what will be the elements of the matrix? Okay. So what will be the elements and how to determine the elements? First, if we consider this element, that is A11, first row and first column, A11. Now you have to see this element is connected with which vertices and which column, which edge. Now see that this is E1, this is V1. Now you have to see in the graph, either E1 is adjacent with V1 or not. Now see that E1 is adjacent with V1. Okay? So there will the element will be 1. If E1 could not be adjacent with V1, then the element would be 0. If the edge is adjacent with the vertices, then the element will be 1, otherwise it will be 0. Now I will suggest you to write the matrix column by column. Now first consider this column, first column. So the edge is E1 for the first column. Since you know that an edge is adjacent with two vertices, exactly two vertices. So E1 here in the graph you see that E1 is adjacent with V1 and V2. So there will be two ones in V1 and V2 and all the other elements will be 0. The reason is E1 is not adjacent with V3, V4, V5, V6 and V7. E1 is adjacent with V1 and V2. This is the process and this is very simple. Now we are going to second column and the edge is E2. Now see that with which two vertices E2 is adjacent. Now see that in the graph E2 is adjacent with V2 and V3. So put 1 in V2 and V3. 1, 1. And all the other elements will be 0. Similarly for E3, E3 is adjacent with V3 and V6. So V3 and V6, I am putting 1 in these two places and all other elements will be 0. So in this process we can complete this matrix. Similarly for E4, E4 is adjacent with V3 and V4, sorry, this is E4. E4 is adjacent with V3 and V4. So V1 will be 0, V2 will be 0, V3 and V4 will be 1 and all other elements will be 0. For E5, now see E5 is adjacent with V2 and V4. So V2 and V4 will be 1, 1, 1, all other elements are 0. For E6, E6 is adjacent with V4 and V5. So V1, V2, V3 will be 0. V4, V5 will be 1 and all others are 0. Okay. Now since E7 is adjacent with V6 and V7. So V6 and V7 we are giving 1 and others elements are 0. And for E8, the last edge is adjacent with V6 and V7. Similar with E7, since they are parallel edges, you know what is parallel edges. So 1, 1, 0, 0, 0, 0, 0. So this is our required incidence matrix. Okay. So this was incidence matrix of a connected graph and it is not a digraph. Okay. You know what is digraph? Digraph means a graph which is the edge of which are directed. So here there is no direction in the edges, so this is not a digraph. For digraph there is another there is a small difference for writing the incidence matrix. I will show you next. So this was the procedure of writing an incidence matrix of a connected graph. Now there are many properties of incidence matrix. You can see that in every column there are only two ones, and this is very obvious because every edge is adjacent with exactly two vertices without excluding self loop. If it is a self loop, suppose there is a self loop like this, then there will be, for this edge, there will be only one for that vertices. That is, if we name it as E9, it will be here E9, and we have to put 1 in V4, all other elements will be 0. So if it is not a self loop for edges, if it is not a self loop, then every column will contain exactly two ones, because every edge is connected with two vertices. Next, if you count the number of ones in every row, then you will get the degree of that corresponding vertices. That is, if you consider suppose the first row, in first row there is only one, there is only one single one, so the degree of the vertex should be 1. See, the degree of V1 is 1. Now consider any vertices. Suppose we are considering this V4. So in V4, in this row there are 3 ones. So see the degree of V4. This is V4. I am deleting this. The original graph was this. So this is V4. This is V4. See, the degree of V4 is 1, 2, 3. Okay. Now I am taking another example. Suppose V7. There are only 2 ones in V7. So the degree of V7 is 2. So in this way, you can, from the matrix, from the incidence matrix, okay, if you consider each of the row, you get the degrees of the vertices, and if you consider the columns, you will see that there will be exactly 2 ones in every of the column, in each and every column, excluding it is a self loop. Okay, now I will show you how the reverse procedure, how we can draw the graph if the matrix is given. Okay. This one, the graph is given, we have written the matrix. Now we will show you, if this matrix is given, then how we can draw the graph. Okay, so I am taking incidence matrix. Suppose this is the incidence matrix: 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 0, 0. Now the question is, if this is an incidence matrix of some graph, then draw the graph for which this matrix has been given. So since it is stated that this is an incidence matrix, so we know that the number of edges will be equal to the number of columns, and the number of rows will be equal to the number of vertices. So here the order of the matrix is 1, 2, 3, 4, 5. 5 by 1, 2, 3, 4, 5, 6. 5 rows and 6 columns. So there will be 5 vertices and 6 edges. Okay. So we are naming here E1, E2, E3, E4, E5, E6, V1, V2, V3, V4, V5. Okay. Now since there are 5 vertices, we are placing the 5 vertices. You can place anywhere 1, 2, 3, 4, 5. V1, V2, V3, V4, V5. Now we will draw the edges. Now how to draw the edges? First consider any one edge, suppose E1. Now see, since there are two ones in V2 and V3 for E1, so E1 must be adjacent with V2 and V3. So connect V2 and V3 by an edge, and the name of this edge will be E1, this edge, since there are ones in V2 and V3. Okay. Similar process we are considering, we have already learned for writing the matrix. Just it is the reverse procedure. Now consider E2. E2 is adjacent to it V1 and V4, since there are two ones in V1 and V4. So V1 and V4, we are connecting V1 and V4 by an edge, and the name of this edge will be E2. Okay. Now E3 will be connected with V2 and V4. V2 and V4. Okay. So we are connecting V2 and V4. This will be E3. Okay. Okay. Next, E4. E4 is connected with V4 and V5. So V4 and V5. This is E4. Next, E5. E5 is connected with V1 and V4. V1 and V4. V1 and V4 is already connected with E2. So these will be parallel edges. Okay. So E5 is V1 and V4. So V1 and V4, we are drawing another edge. The name of this edge will be E5. The parallel edges. Next, E6, V1 and V3. So E6, V1 and V3, V1 and V3. V1 and V3, so this is E6. So this is our required graph. So in this process, you can draw a matrix from the incidence. You can draw the graph from the given incidence matrix, and you can write the incidence matrix from a given connected or disconnected graph. Okay. Now I will show you, if the graph is a digraph. If a graph is a digraph, then what is the difference in the adjacence matrix? Okay. Now see that I have taken a digraph. The edges are directed in some certain ways. Now we will draw an incidence matrix for this digraph. So the number of rows and number of columns will be equal to the number of vertices and number of the edges respectively. So here, since there are 4 vertices, there will be 4 rows, V1, V2, I am writing here V1, V2, V3, V4, and since there are 8 edges, so there will be 8 columns, E1, E2, E3, E4, E5, E6, E7, E8. Okay. Now I will put the elements. Now when we are writing the matrix, incidence matrix of a graph, I told you that to put the elements as 1 if the edge is connected with that vertex, otherwise it will be 0. Now in case of incidence matrix, there will be a small difference. I am taking this example, suppose E1. I am taking this edge E1. Now see that E1 is going from V2 to V1 according to the direction. Just follow the direction. E1 is going from V2 to V1. So you have to put +1 and -1 according to the edge is going out from which vertices and going into which vertex. Out vertex, you have to put +1. You have to put +1 in that vertex from which the edge is going out, and you have to put -1 in that vertex from which the edge is going in. So here U1 is going out, U1 is going out from V2, so you have to put +1, and U1 is going into V1, so you have to put -1. So in undirected graph there was no such procedure. You have to put just +1. When it is a directed graph, if it is going out from some vertex, then put +1. If it is going into some vertex, put -1, and other will be 0. Okay. Now for E2, E2 is going out from V2 and going into V3, so you have to put +1 in V2 since it is going out from V2, and you have to put -1 in V3, okay, according to the direction. So other will be 0. Now for E3, in V4 we have to put +1. In V4 we are putting +1, and in V3 we are putting -1. Other will be 0. So in similar way for E4, in V1 it will be +1, and in V4 it will be -1. Okay. So for E5, in V3 it will be +1, V3 it will be +1, and in V1 it will be -1, 0, 0. For E6, where is E6? Now this is E6. It is going out from V2, so this is +1, and it is going into V4, so it will be -1. For E7, it will be +1 for V3 and -1 for V4. Other will be 0. For E8, it will be +1 for V1 and -1 for V4, 0, 0. So this is our required incidence matrix for this directed graph. And now I will show you, if an incidence matrix of a directed graph is given, then how to draw the graph. Okay. So I will take now an example. So this is our required incidence matrix. Given incidence matrix, we have to draw the graph, directed graph from this incidence matrix. And by watching the matrix, you can say that this is a incidence matrix of a digraph, because in the elements there are +1 and -1 both. If this matrix for a undirected graph, then there would not be +1 or -1. Since +1, -1 both are here, so we can say that this incidence matrix is for a directed graph. So before drawing the graph, we are naming the vertices and edges, rows and columns, as V1, V2, V3, V4, V5, V6, and E1, E2, E3, E4, E5. Okay. Now the vertices as 1, 2, 3, 4, 5, 6. V1, V2, V3, V4, V5, V6. There is no such restriction that you have to put the vertices in this place or that place. Okay, you can put anywhere. You know the basic of graph theory. Okay, so there is no such restriction. Okay. Now we'll first draw E1. Now see that E1 is connected with V2 and V4, and since in V4 there is +1, so E1 must be going out from V1 and going into V2. So we have to draw an edge from V4 to V2, from V4 to V2. That is, we have to put this direction as this, and the name of this is E1. Okay. Now if we draw E2, here I have made a mistake during writing the matrix. There is a minus. Okay, so E2 is also, okay, I am putting E2 is going from V5 to V2, because there is +1 in V5. So from V5 to V2, from V5 to V2, and this is E2. Now E3 is going from V1 to V6, +1 that is going out from V1 and minus 1 that is going into V6. That is V1 to V6. V1 to V6. Direction is this. And the name of this edge is E3. Next, E4. E4 is going from V6 to V1. E4 is going from V6 to V1. That is V6. Where is V6? V6 to V1. So we have to draw another edge, but the direction will be this, and this is E4. These are parallel edge. You can see that. Next, E5. E5 is going from V1 to V4. From V1 to V4. From V1 to V4. That is, this will be like this. And the direction will be this. And the name of this edge will be E5. So this is our required graph. And you can see that this is a disconnected graph because V3 is not connected with any of the other vertices. So this is a disconnected graph. That is not a matter about, this will not be a problem for writing the matrix or graph. It may be a connected graph or disconnected graph. The procedure is same. Okay. So this was the procedure how to draw the digraph if incidence matrix is given. Now a basic property of incidence matrix for digraph, you can see that in every of the column there is 1 minus 1 and 1 plus 1. What is the reason? Because every edge must be going out from some vertices and must be going into some vertices. So there will be a plus 1 and a minus 1. Okay, so if you consider the rows, and you count the number of plus 1, you will get the out degree of the vertices. And if you count the number of minus 1, you get the in degree of the vertices. Since because see this row, you can see that there are 2 minus 1. That is, the in degree of the vertices is 2. So that is 2 edges has been inserted into V2. Now see the graph. This is V2. This is V2. Now see that 2 edges has been entered into V2. So this is called in degree, and out degree means number of edges who has going out from that vertex. Suppose if we consider this vertex, there is only 1 plus 1 and 2 plus 1 and 1 minus 1. That is, out degree of this vertex will be 2 and in degree of this vertex will be 1. Check it. V1. This is V1. Now see that one vertex is going out, another vertex is going out. So 2 is the out degree and one vertex is going in. So 1 is the in degree. So number of minus 1 will be the in degree, number of plus 1 will be the out degree. And if you add these 2 degrees, that is out degree and in degree, you will get the degree of the vertices. That is, degree of this vertex is 3. That is, there are 3, 1. It may be either plus 1 or minus 1. Okay, so this was the procedure how to draw a incidence matrix. How to write an incidence matrix of a graph, undirected or directed graph, and you can also draw the graph from the given incidence matrix. So this was for all this video, for this video. Okay, in the next video I will teach you another matrix representation of a graph, and that is called adjacency matrix. Okay, so you have to practice this type of problems. If you face any problem during practicing, you can contact me. My contact details is given in the first slide of this video. Thank you.